All right, good morning. Coming back from a weekend. I think I'm gonna do two examples today. We got some bad weather coming. It's a chance that we might not have school tomorrow based on what happens with the snow. So I'm gonna do like a couple of examples. It's gonna be straight ACT questions, and these two in particular that I'm gonna go over, at least the first two, are gonna be basically like a geometry connection to the Pythagorean theorem. So it's different ways that they present you with a Pythagorean theorem. So I'm gonna go over a couple of those. If a rectangle measures 42 meters by 56 meters, what is the length in meters of the diagonal? So here's your multiple choice question, and there's your selections, all right? So I'm not going to go directly into how to solve it. I'm going to go directly into how you think about the numbers and maybe do some elimination on the front end. One of the best things to do is if you're given a problem that gives you a shape, a description of a shape, draw that shape. All right, so what I have here is a rectangle as described, and that side right there, the shorter side, that's 42, and this along the bottom is 56, all right? Just like the instructions said, you had a 42 by 56. Now that I have the shape in front of me, I'm going to create my diagonal. And it doesn't matter which corners you connect, it's going to be the diagonal regardless, either direction. So there's my diagonal. And so if you pay attention to what just happened there, I created two right triangles. Now I have two right triangles. So whenever you're dealing with a right triangle, 9 times out of 10, you're going to have to use a Pythagorean theorem. There's a time that you won't, but I'm going to tell you what to look for so that you know for sure it's time for the Pythagorean theorem. So number one, if you're dealing with a right triangle and you know two of the lengths, the missing length is always found through the Pythagorean theorem. So you got to have one missing side on a right triangle. That's how you know you have to use a Pythagorean theorem. One missing side on a triangle is a Pythagorean problem every single time. So remember the hypotenuse, because that diagonal happens to be the hypotenuse of the right triangle we just created. And if the hypotenuse is the longest side on a right triangle, your numbers have to be bigger than 56. See, 56 is the largest number between those two. It's got to be bigger than 56. So off top, we have two wrong or incorrect answers. The hypotenuse can never be smaller than the other two sides. So those two are wrong. So that leaves us with three selections. So right there, you just increased your chances, even if you don't know how to get the correct answer. So I've already put this into the software because I didn't feel like drawing it out by hand. So like, here we go. I'm going to hit this button. We're going to look at the diagonal and it's going to tell us what the length is. See, look at that. The diagonal is 70 meters long. All right. The diagonal is 70 meters long. So the correct answer is 70. All right. The correct answer is 70. All right. So I have a rough sketch of the right triangle now. I got my 42 going right here. I got my 56 going right here. And we know that the Pythagorean theorem is a squared plus b squared is equal to c squared. The part that says equal to c squared, the hypotenuse is the one that sits by itself, all right? The legs that we have here, the horizontal and the vertical one, or whichever one of your legs are, they're always together. That's your a squared plus b squared. So I have 42 squared plus 52 squared is equal to the hypotenuse squared. All right, 42 to the second power, that's your 1764. 56 to the second power is 3136. All right, so 1,764 plus 3,136 is equal to 4,900. And that's my hypotenuse squared. So if we know anything about our numbers, we know 7 times 7 is 49. So 70 times 70 is 4,900. All right. So the hypotenuse has to be 70. A painter leans a 35-foot ladder against a house. The side of the house is perpendicular to the level ground, and the base of the ladder is 15 feet away from the base of the house. To the nearest foot, how far up the house will the ladder reach? All right, so this is a lot of reading. Like you have a few lines of text you have to read through. When you have that many lines of text, just jump down and read the question. just to make sure you understand, okay, out of everything that you're about to read, what do you want to know at the end? So just kind of read that one first. So you want to know, okay, how far up the house will the ladder reach? Then go back in and read what the descriptions say, because it's such a long problem to read. Always jump to that question first. It's very important that when you read a question like this, especially when you have the types of descriptions that they give you, use those descriptions to draw a diagram. Always use your descriptions to draw a diagram. So here's my diagram. I have a house. As you can see, you had a 35-foot ladder. That's the diagonal, also known as the hypotenuse on the right triangle. And how do I know it's a right triangle? The description said that the side of the house is perpendicular to the ground. So if the side of the house, which is this side here, is perpendicular to the ground, then it creates a 90-degree angle where they meet. All right, so there's your description there so that you know for a fact you're dealing with a right triangle. Now, 15 is across the bottom because the base of the ladder is 15 feet away from the base of the house. That's why 15 goes there. The question wants to know how far up the wall does the ladder reach, all right? So I have my description. It goes along with what I've read. So then from here, I can go straight into a Pythagorean theorem. Remember, I have one missing side on the right triangle. All right, so certain facts never change, right? And the fact of the matter is, anytime you're dealing with a right triangle, the hypotenuse is the longest side of that triangle. Now, if I gave you the hypotenuse, I think the hypotenuse here is 35. That means H cannot be larger than 35. So we know for a fact that whatever our answer is, it cannot exceed 35 feet. So based on that, I just flip it, and then I know that these two, which is 38 and 50, I know those two are out the question now. Out the question. They cannot be correct because those two happen to be bigger than the hypotenuse. And on the right triangle, nothing is longer than the hypotenuse. All right, so I use my Pythagorean theorem. A squared plus B squared is equal to C squared. Remember, C squared, the one over here by itself, that's the hypotenuse. So the other two are the ones that I have to write here. All right, so H squared plus 15 squared is equal to 35 squared. 35 times 35 is 1225. 15 times 15 is 225. And then I bring down my H squared. So we're going to solve this equation out. And then from here, that should give us how tall this ladder is or how far up the wall it reaches. All right, so I went ahead and worked it out. So I'm explaining it line by line. So you subtract 225 on both sides. That's how I get my 1,000, bring down my H squared. Since this has a second power on it, I have to take the square root of both sides. And now I know H is approximately equal to this decimal. So the question wanted to know to the nearest foot. All right, so I have 31.6 feet that I'm looking at here, which means to the nearest foot, my correct answer would be 32. So 32 is how far up the wall the ladder has reached. So those are my two examples, straight ACT types of questions that uses the Pythagorean theorem. All right, so it's other ways that you may get hit with a question and the Pythagorean theorem will apply. I'll try to find a couple more of those and then maybe do another example of those if we have class or school tomorrow. So don't forget, you can always subscribe to my channel on YouTube. You can follow me on Instagram. And I put up videos every day I report to work. Every day I report to work, I'm doing a video.